Hello, everybody. Welcome to today's webinar, Mass Timber High Rises Returning to Chicago After 150 Years. My name is Twyla Neely-Strite, and I'm the Education and Operations Associate at Illinois Green Alliance. Today's program was put on by the Illinois Green Alliance Programs Committee, a volunteer group that coordinates education events covering a wide range of topics throughout the year for the green building industry. The team that put on today's event consists of Jason Meyering, Alan Dussault, and Tom Dietz. You've all been muted upon entry, so please type any questions you have into the Q&A function and we'll get them answered at the end. This webinar is being recorded and will be sent out to you in a follow-up email. For those who are unfamiliar, Illinois Green Alliance is a membership-driven nonprofit organization that advances green buildings and sustainable communities for all. Our 5-year strategic plan pushes the green building industry to meet or get on the path to net zero. We achieve this work through education events such as panels, building tours, and more, and by engaging communities and partnering with organizations across Illinois, and by advocating for new policies and legislation. Members can view our recorded webinars on our on-demand webinar library. You can also learn more about membership, see upcoming events, and get involved by visiting our website, illinoisgreenalliance.org. I want to take a moment to recognize Illinois Green Alliance's sustaining sponsors who make our work possible. A special thank you to our gold level sponsors, ComEd, Resource Innovations, Sloan, and USGBC. Make a commitment to advancing green buildings in communities across the state. Start a conversation about sponsorship or partnership today at illinoisgreenalliance.org/sponsorship. We have a great lineup of speakers for today's program. First up to speak will be Bobby Larson, Senior Associate at DLR Group. Practicing from DLR Group's Chicago studio, Bobby is an architect with a passion for community. He finds it rewarding to have a role that can physically and tangibly influence the spaces and places for life, work, and play. While specializing in hospitality and workplace environments, he also champions cutting-edge sustainable solutions and leverages his experience in mass timber office building design to apply new ideas. Bobby views environmental responsible design as doing more with less, and that the best design overlaps the 3 pillars of sustainable design: economic viability, social equity, and environmental responsibility. Next, we'll hear from John Mitchell, Associate Partner at Hartshorne Plunkard Architecture. This Chicago-based design firm is at the helm of several of the country's most significant mass timber projects, including Sterling Bay's 2100 North Southport project, anticipated to be Chicago's tallest mass timber building. Other projects include T3 West Midtown in Atlanta, Nashville Warehouse Company, and the Intro project in Cleveland, which was the nation's largest mass timber construction building when completed in spring 2022. Since joining HBA in 2004, John has led the design team for several of the firm's mass timber projects, including Intro and 1036 West Fulton, one of the first multi-story timber office buildings built in Chicago in a century. After we hear from our speakers, we'll have an audience Q&A led by Jason Meyering of Jason Meyering Architecture, a 6-year veteran of the Illinois Green Alliance Programs Committee and a primary contributor to the development of this program. Jason works to promote innovative building technology and techniques and the achievements of sustainable practices and projects. Jason's practice focuses on architecture, interiors, sustainability, and the intersection of living, working, and learning through specializing in education and residential design. Now I'm going to hand things over to Bobby to start us off. And Bobby, take it away.
Thank you, Twyla. Just give me a second to get my presentation pulled up here, and we'll get started. I'm really excited for this opportunity to speak with everybody today. Apologies, just a second. I'm very passionate about the opportunities that mass timber provides to our industry, and I'm really excited that there's as many people as there are interested in it along with me as well. Okay, giving you a preview. All right, so I'm going to start off here with a pretty bold statement that mass timber represents the most ecologically important disruption of the construction industry in the last 100 years. And there's been a lot that's happened in the last 100 years in terms of energy efficiency and new technologies that have improved our buildings. But mass timber is making an impact in a way that is going to be key to our future as we try to rein in global emissions. And I'll get into that as I go through my presentation. But before we talk too much about that, I'd like to just kind of share a little story about myself. So 10 years ago, I was living in Oregon, and I went and saw a project that I hope many of you are familiar with, which was the Bullitt Center that was constructed in Seattle. And that project was extremely unique. It was the project that was built as part of the International Living Future Institute's initiatives and where they have their offices. And it came together and they had to basically rewrite the Seattle code to make it work. And it was pretty expensive in terms of comparable construction practices, but they did it, and it was an example of how construction could be. And when I saw that at the time, I thought that it'd be a pretty unique situation where that project could have actually happened. Typical building projects, budgets are tight, and we don't have as much opportunity to dream as they did in that case, where they had some generous funding sources. But I moved to Chicago soon afterwards and started working for DLR Group, and was very pleasantly surprised to see that it was happening. It didn't just stop at that one building. Other people were seeing that as an example of what things could be. And we had the company DLR Group had just recently completed this project. This is the T3 Minneapolis project in Minneapolis, which I think many people might be familiar with on this call. But I want to tell the story about this project a little bit too. So this came about as part of a change in office culture. It used to be that you had these CEOs and lawyers that wanted to be in the central business district, on the top floors of a glass tower. And there's this big shift in workplace design and companies, where instead of the old CEO who was all about that prominence within the social structure, we have these hoodie-clad tech people coming out of college, and they were demanding a little bit different environment for their workplaces. And at the same time, the client that we're working for, Heinz, they were noticing a trend with a project that they had in Minneapolis. There's this old loft building, as a picture of it in the top right. And what was going on is that it was one of the buildings that leased up the fastest. People would tour it, they'd see the beautiful wood, they'd fall in love with the kind of the historic nature of it. But even though it leased up the fastest, it had some of the highest turnover. So after being in the building for a year or so, they realized that the elevators were old and broke down. There weren't good pathways to route all of their data and everything that they would need for their modern workbenches, and the building was drafty. And so the idea was generated to redesign and create a new timber loft office building. And that was enacted there. The other part of this is the location where this is happening. Timber has some unique constraints to it. It's limited in size, and it doesn't necessarily make as much sense in central business districts where you have to build tall in order to justify the expense of the land. But it does fit really well in places that like Fulton Market, where the surrounding building environment is a little bit shorter. The buildings are historic in nature, and timber makes a much better fit. And so, we're using this material, and as you know, with wood, it's a renewable material. It grows naturally. It's very different than the alternatives that we have for this size of a building of concrete or steel construction. And it's important that as we design these spaces, that we're taking advantage of both the aesthetics and the way that these materials are manufactured. One of the biggest advantages that I'm sure that an Illinois Green presentation a lot of you are interested in is the amount of embodied carbon that we can avoid. And so the embodied carbon, I hope that a lot of you are familiar with that term, is the amount of carbon that it takes in order to manufacture, transport to site, and erect any given material. And on T3 Minneapolis, because we used timber instead of a concrete building, the total volume up there on the top was 148,947 cubic feet of wood, which sounds like a lot, but in North American forests, it only takes about 14 minutes for that amount of wood to grow. So we don't necessarily need to worry about the fact that we're cutting down trees. We do have a substantial amount and replenishes all the time. That equates to 6,001 metric tons of carbon dioxide avoided. A lot of that being stored within the wood itself, and a large portion of that being the fact that the wood just takes less energy to produce than concrete or steel, and that equates to almost 1,300 cars taken off the road for a year. When we designed this building, because it's in this historic area, we wanted to relate to that aesthetic. We wanted to make sure that we responded to the this old style of punched openings and real natural materials like brick. One interesting thing about timber that we discovered as we were designing it is that the heavy materials didn't necessarily work as well on our timber slab edges that we cantilevered past. And so rather than trying to make the timber do something that it might not be as well suited for, we ended up doing a lighter material. We ended up with a core 10 metal panel instead of the brick, just to kind of leverage it for its strengths and not try to make it do something that it wouldn't do. And here's a picture of the interior, and you can see that it would definitely differentiate itself from a typical office that might be leased out to somebody in Minneapolis. If you can imagine yourself walking through 6 or 7 spaces throughout the day and seeing concrete columns and concrete slabs, and then walking through this space and noticing the warmth and the color of the wood, and really feeling a difference. Because of that warmth and color, as we design these buildings, we make sure too that the other materials that go against it follow that precedence of natural patterns and beauty. You wouldn't want to put a fake material up against your wood column because it would really show off the fact how fake it was. So on this project, we used other natural woods and other materials that had patinas like board form concrete and blackened steel. And this is what it looks like for some of those interior fit outs. And it's really interesting thing that, that it's kind of this relationship between the fact that you want to expose the timber and there's code requirements. So you'll notice that all the ductwork and things are exposed on the ceiling, and that's partly because you want to see the beauty of the wood, but there's also limitations on timber construction where you're not allowed to have concealed spaces. And so that forces your hand a little bit and makes you think a little bit more as an architect as you design these spaces. And some of these things that are sometimes forgotten, like how the conduits are run, or even what color the conduits are, you have to start to think about and make sure that you integrate into these spaces. And these are photos of an interior fit out of that project that was done by Perkins and Will. Since T3 Minneapolis, we've continued to work with our client Heinz, and we've done a number of projects across the country, including the T3 Minneapolis project that HPA worked on. And it's proven as a good concept, and people are starting to really see not only the environmental benefits of it, but also the economic benefits as well as these projects open up into new markets. And it's proven to be successful in a variety of locations across the country. And we've been excited to be a part of it. And the title of the session that we're in is Timber High Rises back in Chicago. And that wasn't always necessarily the case. So one thing about the code that we were always running into is that there's a height restriction on the timber. And if you're familiar with the building code, the high-rise designation occurs after you're 75 feet above the highest occupiable floor. And the timber height restriction that we had was that we could only build up to a maximum height of 85 feet. So we're technically still mid-rise buildings, but it's very interesting to see that as this project have been more adopted and shown up more and more places, that the timber codes have been evolving to recognize the fact that we're doing these buildings in new ways, in safer ways than they were done 100 years ago. And we're going to start seeing a lot more projects like the tower in Milwaukee, the Ascent Tower, and the towers that HPA is going to present on that are 18 stories tall, 20 stories tall, however it may be. You know, these are possibilities that are opening up for us. And when we're talking about mass timber, we're talking about something specific. You know, in the code, it talks about heavy timber, and it does talk about mass timber a little bit. If you look at the code book, it says, you know, HT construction, and that is in itself is kind of historic. Heavy timber references solid cut wood. You take a log, you trim the sides off, and you have a solid square piece of wood. That's heavy timber. Mass timber is something that has come about. It's not new, you know. I'm not exactly sure the exact date, but 50 years ago or so, that people started gluing together wood in a way that you get larger pieces. And that helps because then you don't have to necessarily cut down gigantic trees all the time to get your big beams out of them, but you can use smaller trees to do so. So you have these glue lams used as beams that are all just glued together. And then there's other products as well. Both the Bolt Center and our T3 Minneapolis project use something called NLT, which is basically 2x8s stacked on end and nailed together. And I don't know if anybody makes that anymore. They've kind of advanced that process a little bit more. And there's a product out there now called DLT, which doesn't have any nails in it. They actually ram wood dowels through those 2x8s to make a solid panel. And then the most prevalent product out there on the market is something called CLT, where they take these wood pieces and they, instead of putting them all on end, they lay them in a crosshatch and glue them all up, make these big, massive panels to make building elements. The next project I want to talk about really quick is this T3 West Midtown, and that we finished a number of years ago, and it followed a lot of the same criteria that we did on the Minneapolis project, where we wanted to put it somewhere where it made sense. It's in an area of Atlanta where it's close to transit. The site that it's on used to be an old steel mill. And you can still see that flue out in that park out in front of the building. That's a remnant from that. So it kind of has this industrial heritage a little bit. And we designed it, you know, to the limitations that we had, which was to do 7 stories tall, the bottom being out of concrete, and 6 stories of wood on top of that concrete podium. And as you can see, you know, it has this beautiful interior as well. One thing that we did different on this project is instead of doing a concrete core, we ended up going with a braced frame. And that was helpful because we didn't have to wait for the guys to form the concrete core. We could put the wood up pretty quickly. And as the guys were putting up the wood, they could put the braces in as well at the same time. And it led to a little bit faster construction time for that project. And we continued to develop kind of our tool set and worked on ways to integrate the MEP to keep it from diving too low underneath beams and things like that, as something that we needed to think about in the design of these buildings to make sure that we aren't leaving a big cobbled together mess at the end of the day for people when they lay out their interior fit outs for these offices. And this is a couple pictures of something where we upturned the beams around the center of the building to provide for those main mechanical pathways. And it helped to provide a way for that to happen without disrupting the view of the ceiling spaces. And this is a picture of that project being erected. And it's really interesting to see these go up. I'm not sure if any of you have ever seen a concrete crew before, but these are built a much different way. Concrete, there's all the forming and finishing and all the concrete trucks that show up and pump and all these other things that go into the work. And the timber shows up on site like a big kit of parts. It comes together a piece by piece at a time that are all digitally fabricated and ready to be placed. And it can be faster, can be quieter, and it doesn't necessarily require as many people to put up. So there's advantages to that as well in the construction process. But now I'd like to talk a little bit about these big environmental benefits that we have from using wood. And to really tell the story of wood, we have to have a good understanding of what the impact is of the built environment onto the climate situation that we have. So there's a pie chart on the left that shows the world's carbon emissions and how they get broken out. And the total impact from the built environment, as you can see as on those yellow portions of the pie chart, is that we're looking at about 39% of global emissions come from buildings, 28% being from the operation of those buildings, how much energy it takes to heat and cool and light those buildings, and 11% coming from the construction. And that 11% is what we call the embodied carbon. That's the carbon from manufacturing and building those structures. On the right is a little bar graph. This is also interesting to see. This is for one building, one typical building. When you're talking about the lifespan of that building, the portion of that building's carbon that's embodied, that's built day one, that's 49% of the total emissions of that building as compared to the operational carbon, nearly half. And it's something that we haven't talked as much as we should have to date. And so just to kind of understand that term a little bit better, this is how that works. So you have these different stages of life for anything. It could be a ceiling tile, it could be a beam. And you start out and you have to mine whatever that product comes from, you manufacture it, you ship it to the site, you install it. There's this blue thing in the middle of this graphic, which is the operations carbon, which isn't necessarily part of the embodied carbon story, but it is for the total carbon story. And then there's maintenance and repair cycle for that material, the eventual deconstruction of it, and the waste process disposal. We consider the whole life cycle of any material when we're starting to assign it those numbers. Here's one other graphic too that illustrates another point that's important to make. And we have another number of pollutants here on the screen that are being shown. Global warming, which is that the carbon emissions that we're talking about. And then there's some others too, the ozone depletion, acidification, eutrophication, and tropospheric ozone. This graph isn't comparing those against each other. It's not that there's more ozone depletion than global warming potential. This graph is showing how much of each of those is occurring at these different phases. And 80% of all of the pollutants that happen occur during the A1 through A3 phase. Let me just flip back for a second. And that's these phases here, the product and construction. So the bulk of our emissions are happening as we manufacture and construct these buildings. And so we get this huge upfront embodied carbon number at the beginning. And this graph is showing the number of years of the life cycle of this building and comparing that to the annual operational carbon. Particularly as we make more and more energy efficient buildings and optimize those buildings, that's going to have an even more significant impact. You can see, on historic buildings, something built in like the 1970s or something like that, it might take 15 years for your embodied or your operational carbon to catch up with the amount of embodied carbon in your building. But now that we're building much more efficient buildings, it might take 50 years before you catch up with that. And so the embodied carbon has an increasingly large impact on the overall emissions of our built environment. Wood in and of itself is also a very interesting material because not only does it take some energy to grow the wood, cut it down, mill it, glue it together, put it in your building, but wood is also 50% carbon by weight. And that's the carbon that the trees take in during photosynthesis and they store within the wood structure. This carbon is something we refer to as biogenic carbon. And in a long-term life cycle, you would plan that at some point that wood would not be in the building anymore. The building would fall down or get torn down or whatever it was. And those beams would sit somewhere and they would rot and all that carbon would be released into the atmosphere. That's not necessarily the case. And if we take a look at Chicago, we talk about mass timber buildings coming back to Chicago. There are tons of beautiful old loft buildings in Chicago that have been standing for, 100 years. It's not a 50, 60-year timeline for these buildings. These buildings are well-loved buildings that people see the value in. And so instead of that wood rotting and being released into the atmosphere, new trees are planted in its place, and those trees, or new trees are planted in the place of the ones that were cut down to build these buildings, and those trees are taking in more carbon. So depending on how you run your numbers, you can actually see a net reduction in your embodied carbon from wood, not necessarily adding to it, as long as we're managing our forests correctly and making sure that we are reforesting at the time that we're cutting down the trees. And the U.S. Forest Service, they understand that cycle. They're saying, we're not bad guys for cutting down trees. And the reason why is a forest in its natural state is basically carbon neutral. So the trees will grow, they'll eventually die, or they'll get burned up in wildfires, and they'll release all that atmosphere into the environment. And that's very different than pumping, 650 million year old trees out of the ground and burning them in our cars. That carbon was going to get released anyways, so we don't feel bad about cutting down those trees and using them to make paper or furniture, or even burn them to generate electricity. We're not adding additional carbon into the system. We're just utilizing that same system. And so some people ask when we give these timber presentations, oh, well, isn't it bad to cut down trees? And, there are some impacts from it, but as long as we're doing it responsibly, we understand that there are huge benefits from doing so. And so in this whole process, if our goal is to create an environment where we're not, doing negative impacts to the world we live in, there's this idea of a total carbon calculation where you're not just looking at operational carbon, not just looking at the energy you use, but you're also looking at the carbon in your materials. And you're always going to have some carbon, embodied carbon, in what you build. And so if you can imagine a building that, it's a net positive building where it produces more energy than it uses, and slowly over time, that energy that it produces offsets the embodied carbon of the building. And so if you want to do that effectively, you need to make sure that your embodied carbon is low. So you build out of mass timber, or you build out of low carbon materials, and you optimize your energy, and you have a net positive building. And in doing so, maybe it's possible that we can build regenerative buildings, and buildings that are not harming the atmosphere, the environment where they're placed. So here's that diagram again, where we're showing that limitation to our office buildings that we've been working on. And let me just touch on this pretty quick, but things are changing. So this is how we stacked those buildings up before. We've got this ground floor of concrete, because wood buildings in offices were used to be limited to 6 stories, and we were able to get 7 stories within 85 feet. But the new codes, the 2021 codes and the 2024 codes especially, are allowing us to build taller buildings and open this construction type up to more places. Instead of these areas where it only makes sense to build 7-story buildings, we're now able to build in areas where 12 to 18-story buildings make sense. And those are the possibilities that we have for the future. And my company has already started to explore that in a number of locations. And I think it's time for me to turn the time over to my esteemed colleague, John Mitchell, and he'll talk a little bit about some of the work that he's doing as well, that I'm also excited to hear about.
Well, thanks, Bobby. And let me pull up my presentation here. Okay, so thank you for everything that you shared there, Bobby. And also want to thank Twyla and Jason and the entire Illinois Green Alliance team for putting on this webinar today. I think that given the amount of people that are here, that this is something that is very interesting. This is there's definitely a desire to do more mass timber, particularly here in Chicago and in the state of Illinois. As mentioned, my name is John Mitchell. I am an associate partner at Hartshorne Plunkard Architecture here in Chicago. And I'm really excited to share with you a few of the projects that we're working on and the things that we've been learning along the way. And I'm going to be taking this from an approach that is very much pragmatic and driven by real estate development. Our firm, we play in the sandbox of real estate development. And so what that means is that market forces drive a lot of our projects. So if we can integrate something into what we're already doing that is demonstrably better for the environment in a way that works with the building economics and all of those other factors, and all the while maintaining something that is an interesting design, because after all, we are architects. Well, then that is something that can scale and begin to truly move the needle with regard to sustainability. And so where our story begins is with the timber loft boom in Chicago in the 1990s, which is when HPA was getting its start. So between 1990 and the early to mid 2000s, we did about several dozen loft conversions and over 1 million square feet in the Chicago area during this time. And we learned quite a bit through that. We learned that there is a market demand. What Bobby was talking about with that office building is the same with these loft renovations in Chicago. High ceilings, great location, lots of natural light, even despite the really funky floor plates, column grids, all those things that you wouldn't really think about for residential new construction, but they were still, these were still desirable places. One thing that we did learn is that every building required its own conversation with the building department, because we were converting these from one use to a different use. There were a lot of existing nonconformities. We were making additions. We were all sorts of different things. And so every building, we ended up going to the Committee on Standards and Tests in Chicago to get these approvals, to prove these equivalencies of heavy timber behaving similarly in fire conditions to non-combustible materials. And so also through this, we thought, well, wouldn't it be cool if we could do these things in new construction? And with that, we have now mass timber. Mass timber, plenty of advantages, and I'm just going to run through this really quickly because some of this has already been covered. Obviously, the structure is the finish. We can erect these buildings very quickly. We can get the speed similar to concrete. And concrete in the city of Chicago, it's legendary for being very, very fast. The concrete crews in Chicago, they know what they're doing. And we can achieve similar speeds with mass timber. And we get to do that without shoring. So all of the other trades can follow very quickly behind. All of the carbon sequestration, the biophilic design qualities of that, we can get to the image on the top right, which is a heavy timber loft building using the materials on the bottom right, which are images of mass timber members being constructed within the plant. Another key feature is that we're less reliant on old growth forests. We can be building these pieces up with 2x members rather than cutting down 200-year-old trees. But there are challenges that go with this. It's still relatively new, particularly here in the United States. We're playing a little bit of catch up relative to Europe, which has been doing this for a lot longer. And so it's still a little unknown to designers. There's a limited number of suppliers in North America. There's some hesitation by the authorities having jurisdiction to embrace these new codes, to embrace these new building types. And there's still not that many. It's increasing, but we're still not there where it's ubiquity of experienced builders. And so that can tend to drive up costs. I'm going to skip over this very quickly because Bobby did a pretty thorough job of capturing the information about the sustainability qualities of mass timber. But I do want to point out one thing, which is the link down at the bottom of this slide, which takes you to the Woodworks mass timber calculator. It's free and very easy to use resource that helps quantify a project that's already done or a project that you're thinking about and what that means in terms of carbon sequestration. And we've used this on several of our projects. And what we found for the residential projects that we do is that for every unit of housing that we do in mass timber, we're finding that we're getting to about the equivalent of taking 5 cars off the road for a year, or the power to operate 2.5 homes per year. And so we find that is just a helpful, not terribly scientific, but also helpful metric just to help explain how this can actually move the needle. Okay, so we've talked about the sustainability aspects, the qualities of mass timber, some of the origins with heavy timber, and how we translate that into now doing new construction, mass timber buildings, and how we can do that at scale. But to be a viable option for high-rise development, we've found that mass timber needs to answer 3 very important questions. There's others, but these are the 3 that we've found to be most important. Number 1, is it safe? And not safe as architects define, but as defined by the AHJ, by the developer, by the market. Number 2, do we have codes in place that allow us to do the types of buildings that we want to do? Can we do a building that we would otherwise do in steel or concrete out of mass timber? And then number 3, which might be the most important, which is how do the financial metrics work? Does it pencil? If it doesn't, we don't have a project. And I think given the current market climate, I think that's something that we all feel pretty acutely, that the financials really have to work for these projects. Let's talk about question number 1, which is it safe? And so Bobby touched on a few of these tests here, and so I'll just recap them pretty quickly here. I want to highlight the first one, which is the USDA compartment test, which was done in 2018. That's the backbone for the 2021 IBC code provisions. All of what you see in the 2021 is based heavily on the results of those tests, plus some factors of safety. And then the next big jump is the RISE test, which is the Research Institute of Sweden, which was done in 2021. And this made a big jump as providing another data point in showing that the char depth, or as you see in the bottom image on the left, all of the black area of the timber, that char depth is as effective as gypsum board encapsulation in preventing reignition or flashover. So what they found with these tests is that the fire just puts itself out. It doesn't keep burning until there's no wood left. 2 other things that are important resources and standards just to be aware of when working with mass timber. One is the NDS technical report number 10, that's the National Design Standard. And that provides standards for designing with mass timber. And then the second one is PRG 320, which is a standard for fire-resistant adhesives in mass timber structures. And that's one in particular in our conversations with local code authorities, fire departments, that has come up quite a bit, of demonstrating that the glue is just as robust as the timber, that the pieces of timber don't delaminate and fall off during a fire situation. The next step is proofs of concept. So have there been buildings that have been built that show that we can do mass timber and we can do projects that actually make sense? And the answer is yes. Right here in Chicago, we have 1038 West Fulton on the left. That was a project that we completed back in 2019. And at the time, it was the first new construction large-scale mass timber office building in Chicago. At 29,000 square feet, which compared to the rest of them in this presentation is actually pretty small, but it was a link in the chain, and a necessary link in the chain. Because what this project proved, and part of what we were doing in our conversations with the Committee on Standards and Tests, was that mass timber can be considered equivalent to heavy timber in fire situations. And then the building on the right, the Nashville Warehouse Company in Nashville, we had a very similar type of conversation with the city of Nashville about proving that equivalency of mass timber to heavy timber in fire situations. From there, we go to pushing the scale. And I'm not going to touch on this too much because, again, Bobby covered this pretty thoroughly, our project in T3 West Midtown in Atlanta that we collaborated with DLR Group on. And this took mass timber about as far as it could with the codes that were in place at the time. And speaking of those codes, we have the 2021 IBC. This becomes a quantum leap in what designers could do with mass timber. So this is the first time where we can break through the ceiling of 6 stories and 80 feet, and we can actually do high rise. And one of the first high rises, true high rises, is Intro in Cleveland. This is a project of 9 stories and about 500,000 square feet of gross area. And this used the 2021 code as a starting point for the scale, for the hourly ratings, for the amount of exposed timber. And it was an 18-month process with the city to get this approved. We started in concept design, and we engaged a code consultant who was actually part of the ad hoc committee that wrote the 2021 IBC code. There were several life safety enhancements that we used to achieve the added height, because Ohio did not have the 2021 code in place at the time. And so we were kind of blazing a new trail with this. So to get that height, to get that added exposed timber, we incorporated non-combustible vertical egress components, so concrete stair and elevator cores. We added more drywall encapsulation of the timber in the corridors. And then all of the timber, regardless of whether it's encapsulated or not, is sized for a 2-hour rating. We learned a ton on this project. We could probably spend an entire seminar just on the lessons learned. I'm going to highlight a few really quick. Number one, the timber fiber volume is a primary, not the only, but a primary cost factor. So if we can keep those fiber volumes low, timber cost comes down. Secondly, we want to align the ideal residential floor plate with the ideal timber grid. So if it's a concrete or steel building, we'd be talking about 25 to 30 foot column bays. We'd be talking about a 70 to 75 foot deep floor plate. And how do we marry that up with the ideal timber grid, which really wants to be around 20 feet on center? And so early on, we worked with our structural engineer partner, Forefront, on this project. And it's critical that you get that structural engineer on board early. Similarly, standardize the bay, the beam, the column sizes wherever you can. The image on the bottom left works great when there is no other systems that are intersecting that, but once we have soffits and drywall partitions and lighting and all sorts of things, you want to keep those timber members standard sizes wherever possible. Last is timber buildings are mostly hybrid buildings. There's not really an all timber building. And so we had to do concrete stair and elevator cores, but we wanted to do concrete stair and elevator cores because the concrete does great with lateral forces. And so we found a way to do that as a hybrid building. And then the last thing is, for maximum schedule advantage, we want to design the building enclosure to be constructed as quickly as the timber structure, which is going to come into play when we look at some of the buildings in the future. How did this building perform? Well, it did great. The timber cost ended up coming in about the same as concrete. So if we can do it in concrete, we now can prove that we can do it in timber. The leasing velocity was very fast. We were 100% occupied within 2 months of opening, and the rents were substantially higher than what our client Harbor Bay had pro forma'd. And then sustainability, we hit LEED Gold, and a lot of that is contributable from mass timber. And the building looks beautiful. So let's come back to those 3 questions. Is it safe? I think we can say, yeah, it's safe. Number 2, do we have a code in place that supports the desired scale? Yes, and I'm going to put an asterisk by that because of the buildings that we're working on next. And then number 3, do the financials work? And I think absolutely they do. So what do we do next? And so we're going to look at 3 projects very quickly, because I know I'm running out of time here, that are on the boards, that are under construction, or that are going to be under construction in 2024. that give us a look into where this is going. And so one of them is 2100 Southport here in Chicago, which is a 9-story, 165,000 square foot building that has been approved by the Committee on Standards and Tests. And so this is now the first building in Chicago that has been approved for over 6 stories, over 80 feet. It's a true high rise in the city of Chicago. We used the playbook that we had established with Intro, and then applied that to here in Chicago. Next up, we have Intro Buckhead, which is in Atlanta, Georgia. And as the name implies, Intro is another collaboration with Harbor Bay and Forefront Structural Engineers. This one is taking the same size of project as Intro. And instead of being 9 stories, we're stretching it all the way up to 22 stories. One of the beautiful things about this project is that 18-month process that we had with the city of Cleveland, that shrunk to 9 months because we walked into that first meeting with the Atlanta code officials and they were gung-ho about this project. They had seen what we had done in Cleveland and we had that instant credibility. We could point to a project that had been done. There was a project team that had done it and we were all together meeting with them. And so there was that credibility, that authority that we could bring to the table right from day one. And with this one, we're applying a lot of lessons learned. A couple of them are, we're reducing the step backs to simplify the structure. It's a high rise, so unlike the wedding cake of Cleveland, we're repeating our floor plate and we're incorporating a window wall system that can be installed just as quickly as the timber structure. And then the last one is the Edison in Milwaukee. And you may have seen some publications about this in the news recently. This is, when it's done, will be 32 stories and probably the tallest mass timber building in the country when completed. This one, because we're getting above that 20 to 25 story height threshold, it is much more reliant on providing a hybrid system to manage the size of those timber members. And so we end up with a hybrid concrete timber floor assembly just to keep those fiber volumes down. And again, as I said, when it's done, it will be the tallest hybrid mass timber building in the United States. And so as I close, I just want to point out that you might have noticed that some of these newer buildings, they don't look too much different from like a concrete or steel building that you might see, at least from the scale, the massing, the outward appearance. And I think that's okay. I think that is part of the goal because we need to be finding ways to take what we're doing now and then make them better methods, better materials, less waste. And having gone through these projects, I think that mass timber is absolutely part of that and can be something that done at scale and done with volume can actually move the needle in terms of sustainability. And now that I've gone completely over my time, I will kick it over to Jason to lead the Q&A.
Thanks, John and Bobby, for your excellent presentations. We have a few questions coming in. Bobby has also been addressing a couple of questions in the Q&A window, so feel free to check some of those responses out. First question that has a couple of the questions are related. In the projects that you've been working on so far, where's the wood coming from? What species are you using? Are these coming from, is it coming from a managed forest? And do you have any comment about habitat in these areas?
Yeah, so what I can speak to with regard to where the timber is being sourced, for Intro in particular, our goal was to source it domestically. And so we had originally reached out to some domestic, and by domestic, I mean North American, timber suppliers. And it ended up being more cost effective for the project to bring it in from Austria. So we worked with a company called Binderholz, who sourced the mass timber, and they were just much more cost effective. And at the time, that was partly a function of the European mass timber suppliers. They had much better product, and they were much more well-oiled machine. I think some of that is starting to trend now toward North America, that the ramp up of the supply chain is starting to catch up, but 5-6 years ago, that was not the case.
Yeah, it really depends on the manufacturer that you go with. So there's a limited number of mass timber manufacturers, especially in the continental US. There's more in Canada currently, but there's more operations opening all the time. Some of them have their own forests. Like some manufacturers, they have their plant right next to the logs that they use to run and make the CLT products, and their own people cut down and mill it and everything. And it's kind of like an integrated process that they make it. Others, they just have the presses that make the elements, and they go onto the open market and purchase, 2x4s as a commodity, and they ship them to their site, and they manufacture the panels out of them. And so that has a lot of variance, and so it's important to have those conversations early on with those manufacturers if you have goals for local wood sourcing. And if you really do want to say, oh, I've got the stand of trees over here, I want to use that, you're probably going to pay a premium, because if you're not, buying it like a commodity off the market and you're trying to do something special, then you're not taking advantage of those market forces.
Great, thank you. Next question is, can you talk about kind of waste in the construction process or waste in the fabrication process compared to some other materials? Obviously, this natural material, and there's some waste associated with it. Kind of what's the efficiency in it and efficiency of prefabrication and stuff like that?
So the waste question, I think one thing people can understand is when you take a round piece of wood and you cut it up into little 2x4 square pieces, there's going to be, parts around the log that fall off and don't get used for the 2x4s. But the wood industry is actually pretty good about reutilizing all that. If you go to Home Depot, you'll find OSB, which is they take those waste pieces and they put them through a chipper and they glue them back together. Everything's kind of held together with glue. Our big columns and beams are, the OSB board is, even MDF, if you know what MDF is, they basically just take the sawdust and they pack that into a panel and glue it all together. So the actual manufacturing process doesn't have a ton of waste of the material. And then because things are digitally fabricated for the panels in a shop, things are more or less custom made to size and then shipped to your site. And so the waste is a lot less than other structural materials.
Great. Can you all also talk about premiums? John, you touched on it quite a bit, but premiums in terms of construction compared to materials like steel and concrete, and also are developers seeing premiums in terms of rent? Are these buildings coming in at different price points than steel and concrete buildings?
Yeah, so in terms of the cost premiums, some of it is a case-by-case basis. For the most part, we are seeing something that is similar, or sometimes a little bit of a premium relative to steel and concrete. Some of that depends on the sourcing. Some of that depends on the general contractor. There was a project that we worked on where we were looking at doing mass timber for that. The general contractor had never done a mass timber project, and frankly, I don't think they wanted to. And so the bid that came in for timber was ridiculously high, and so we had to pivot. There's still a little bit of that friction of getting the right installer, getting the right supplier that still needs to get worked out. And something similar with the revenue side of the equation too. In intro, I mentioned that we were getting our client got premiums that were substantially higher than what they had originally budgeted, and it's a little hard to determine how much of that was just Cleveland's overall thirst for market rate residential rental units, and how much of that was directly attributable to mass timber. But given the continued occupancy rates and that building continues to be 100% occupied even after 1 year of rent cycles, I think it's pretty strong that mass timber is a big component of that.
We did a recent study, and we asked a local Chicago contractor to help us price the difference. And they determined that there'd be basically a 4% premium for the overall building budget to go with mass timber. And John mentioned, in Chicago, concrete guys are really good and they work really fast. And so they knew concrete, and they didn't see the advantages as much as other locations where the speed advantages of timber help you reduce the cost. But if you talk to somebody like Swinnerton, they're a contracting company that they're trying to differentiate themselves as being specialized in mass timber, and they've even kind of set up their own little offshoot design and manufacturing group called Timber Lab. And in conversations with them, they say all our cost models show timber being comparable or cheaper. So it really does depend on the local market and who it is that you're working for. But you know, you might be kind of here, you might be kind of here. It's going to be not astronomically more expensive, but likely to be more expensive by a little bit.
Great, thank you. A couple of related questions here. Relative to earthquakes or pests and stuff like that, have you seen a difference in construction types or details between different regions that you're working on these projects?
Yeah, it's
Yes.
a great question. Go ahead, Bobby.
So certain regions of the country have to worry about termites. And so it's not everywhere that you necessarily have to worry about the termites. Most of the projects that we've worked on have had the concrete podium underneath, and that was to maximize the building height based off the number of stories. And if you have 7 stories and only 6 can be in timber, you end up with a concrete floor. If you have a concrete floor, that mainly kind of takes care of the termite problem, because you're worried about the bugs making their way inside, finding the wood, and going, oh, this is great, and then going up. And that doesn't happen everywhere. In the southeast specifically, there's a lot of termites, and we've had to like treat the perimeter of the building or treat the base of the columns, so that the bugs don't get into them. And then earthquake, so on a project that we were working on the West Coast, we had to turn some of our timber columns into concrete at the brace frames to make sure that they were rigid enough to resist all the lateral forces.
Yeah, and to that point with lateral and earthquake, the name of the test is escaping me. It's fairly recent, and where there was a mock-up that was done of a timber tower that was subjected to some simulated earthquake loads, and preliminary information is pretty promising with that. So this is one thing where we're just on the cusp of the research that's being done, and more is going to be coming in. And so as this relatively young industry continues to evolve, we're going to get more and more data points to work with.
Great, thank you again, guys. Maybe one, Twyla, if we can do one quick question, one closeout, final thoughts. How do you see Chicago compared to other municipalities where you're working in? What's Chicago's future for mass timber?
Absolutely is part of it. There's a reputation, and maybe it's deserved, maybe it's not, that there was some fire over 150 years ago that seems to be leaving some scar tissue with the city and its hesitation towards wood. But I feel like, and I think our project at 2100 Southport is evidence of that, is that the city is definitely liberalizing toward embracing mass timber. Is it going to be on every corner of the city? Maybe not, but it's absolutely going to be part of the toolkit.
Well, thank you all so much for taking the time to share with us and our audience, and we really appreciate it. For those still on, I just want to remind you that this is recorded, and we'll be getting out a follow-up email through Eventbrite to all of you that will have this recording and a copy of the slides, and then we will try to get our speakers to answer a few more of these questions in a Q&A document that we will send out as well. So thank you all for joining, and I hope you have a great day. And thank you again to our speakers, John and Bobby, and thank you, Jason, for moderating. Have a good one, everyone. Bye.
Thank you.
Thank you.